Okay, we're on page 28 of the book. So this process of finding the gradient function is called differentiation. The gradient function is also called the derived function because it is derived from the original function. Other terms used include derivative function, the derivative, or it's also called the first derivative. Now, the gradient function of the original function, which is function of x, is written or denoted as f dash x. However, there are several different forms of notation that can be used to denote the gradient function. These are y dash, y with a dot on it. Now, they only really do that when you're looking at motion. All right. dy dx. This d by dx is the change in y with respect to x. dy dx is the change in y with respect to x. That's rise over run, girls. How's y changing with x? dy is like delta y. Remember we did that delta symbol? That's the change in y. That's your rise, y2 minus y1. And your dx is x2 minus x1, but that's only for a straight line. Remember when we looked at all that process of finding the gradient of the tangent to the curve, we were looking at the gradient of the secant and the limit as h approached 0. So because it's not a straight line, it's not y2 minus y1 over x2 minus x1, but it's the limit as h approaches 0 of as that other point gets closer to the x value that you want. So it's called dy dx, change in y over change in x. Or like this. This is dy dx, but they've just got the y separate in a bracket. All right, d by dx of the function of y. So it's differentiating. D by dx is to differentiate the function with respect to x. All right, so for example, if y equals x cubed, then the gradient function can be written as follows. Y dash. See, y dash reads as y dash. So if y equals x cubed is your original function, then y dash equals 3x squared. Or I could have written dy dx is, so I can write either y dash or dy dx is 3x squared. The other way I could have written it is, let's see if they do it down here. Yeah, they do. Okay. Oh no, it will. So the other thing I could have done is, where's my text box? I could have done it like this. If function of x equals 3x, I can't do the power, but you know that's x squared, right? Then you could have written it like this. Then f dashed x equals, sorry, if y is x cubed, then this is the other way we could have written it. Then f dashed x, this is what we were doing before, is 3x squared. All right, you write it with proper powers. So we could have written it that way. If y equals x cubed, then y dashed is 3x squared, or I could have written dy dx is 3x squared. Now, why will you sometimes write it like this on the left or like this on the right? It depends how they give you the original function. If they give you y equals, then you write y dashed equals or dy dx equals. Got it? If they write it and give you the original question as function of x equals, then you write f dashed x equals. So the notation's the same and consistent. All right? So if a function y is defined in terms of x, what we mean, that could be like y equals 3x squared plus 5x. That's y is defined in terms of x. Then the process of obtaining the gradient function is called differentiating y with respect to x. So here's my original function, y equals x cubed. If you differentiate y with respect to x, you get dy dx is 3x squared. Or I could have written y dashed is 3x squared. Or if you've got y equals x to the power of 4, that's your original function. If you differentiate that with respect to x, we get that y dashed is 4x cubed. That's your derivative function or your gradient function. Similarly, if a function h is defined in terms of t, or f is defined in terms of x, you know how we did function of x? Remember, you can use any letters. It doesn't always have to be f bracket x. It can be h bracket t. It can be h bracket x. All right? So if a function h is defined in terms of t, your original function would be called h of t, right? So you are differentiating h with respect to t, and your derivative function will be h dash, which is 6t, or you could still write dh dt. I'd probably go with the h dash in this case. All right. Now, all right, these are our short methods of differentiation. So we're on page, oh, something's, okay, we're on page 29. Okay, so if y equals x to the power of n, then the gradient function y dash, or dy dx, is, remember, bring the n to the front, write the x out, and drop the power of n by 1. So if y equals x cubed, then y dashed is 3x squared, what we were doing before on the board. Our second result, if y equals k times x to the n, then the gradient function y dash, or dy dx, is k times then the derivative of the x to the power of n, which is bring the n to the front, write the x out, drop the power by 1, n minus 1. And here's an example. If y equals 5x cubed, then y dash is, we keep the 5 there. Look, I like to write the 5 first, but it doesn't matter. Error in this, that's wrong. It should be, I would not write it like that at all. So I'm just going to cover that up. Right? So if y equals 5x cubed, then y dash equals the 5, right, times the derivative of the x cubed, which is 3x squared. So 5 times 3 is 15, so we've got 15x squared. Don't put, you know how to write it, guys. You don't write the little hats, all right? X1, if y equals just a constant, okay, then the gradient function y dash is 0. Now, this is because of the following. There's a few ways we can do this. So if y equals k, if I ask you sketch y equals 2, y equals -2, it's just a horizontal straight line. What's the gradient of that line? What's the gradient? 0. You know how at the beginning gradient of flat lines is 0, gradient of vertical lines is undefined. There is no rise, that's flat. Okay, so the gradient of this line is 0. So horizontal lines have a 0 gradient. If I asked you, yes, give me the equation of this line, you could write it as y equals 0x. Remember, all straight lines are y equals mx plus b. All right? The gradient of this line is 0, so it's y equals 0x plus b. All right? So the gradient of that line is 0. So if your original function is y equals k, a constant, then y dashed is 0. So the derivative of a constant is 0. Okay? Good. Now, another example here, or another rule, is if y equals the function of x plus g of x, there's two functions combined together, then the gradient function y dash would be just f dashed x plus g dashed x. You just differentiate each one separately and you add them together. All right? So, oh no, they've just sort of written it as one, sorry. What they're saying is treat each component of the original function separately. So, x cubed, you differentiate that. Minus 5x squared, you differentiate that. You differentiate the 9x and you differentiate the 8. So, if y equals that, then y dash is, look, bring the 3 to the front, write the x out, drop the power by 1, 3x squared. With the 5, remember it's minus 5 times, differentiate x squared, and what do you get? 2x. So it's minus 5 times 2x, which is minus 10x. Now, if you look at something like 9x tool here, so we're okay with the minus 5x squared, but if you look at 9x, look, this is really important. If y equals 9x, let's just look at that bit. That's really 9 times x to the power of 1. So isn't y dash this y equals 9x bit, ladies? So if y equals 9x, that's like 9x to the power of 1. So y dash there's the constant, 9 times, bring the 1 to the front, 1x to the, drop the power of x, of the x by 1, which gives me to the power of 0. Now, are you okay with that? So, what's x to the power of 0? 1. So, it's 9 times 1 is 9. This is another very important rule, that the derivative of something, so everyone's fine, they can differentiate x cubed and x to the power of 4 and all those, but some people get a bit stuck when they're differentiating something like 9x. You're dropping your power of x by 1, and the power of x at the moment is a 1, so it comes to the front, x, and the power of x to the 1 gets dropped to x to the power of 0, which happens to be 1. So it's 9 times 1, got it? 9 times 1, which is 9. So we'll practice more of these. So if you have more than one term in the function, you differentiate each term. Okay? So for the first one, it'll be 7 times 4x cubed, which is 28x cubed. With the second one, it will be, bring the 5 down, x to the power of 4, minus 8 times 2, bring the 2 down, 2x. So minus 8 times 2x is minus 16x. What about the next one? So it's saying use d by dx. Oh, all right. So with this one, wait a minute. I just want to show you what they mean here. So girls, this one is a bit different. I want to show you. They're just saying, see here they've defined it. They've said function of x equals that, so we use f dash x. Here they've said y equals that, find dy dx, so we say dy dx. But here they're just saying differentiate this. So the way we need to write it is d, I need to put, this is over dx, okay? So I need to sort of underline that. D by, can you put d over dx? But what I need is now, so go d by dx, use d by dx notation. You don't say y equals this or whatever. You say, if I differentiate this particular thing, so I go d by dx of 5x cubed. I'm just going to go like this, all right? No powers. I'm tired of doing powers. Got it? You know what it is, right? That's how you write it out. So d by dx of that equals, is how you write it out. I'll make this bigger. I know why you're getting confused. I'll put the powers in. So d by dx of 5x cubed minus 2x squared plus 9x plus 3 is, and then you just put, that's how you can set it out as well, equals 5 times 3, that's 15x, what do we get? 15x what? Squared minus 4x plus, I miss, thank you, plus 9. Now if you differentiate the constant, you get 0. Girls, why? Tell me what could be. You know how that's plus 9x? Couldn't that be 3x to the 0, for example, next to that? You can think of your 3 as 3x to the 0. Look, if you differentiate, look, you're supposed to be dropping a power of x every time. There's no power of x here. Or you could think of it as x to the power of 0. If you bring that 0 to the front, you're timesing by 0. All right? So if you differentiate a constant, you get 0. 9 plus 0, you don't need the 0. So when you differentiate a constant, you get 0. Don't worry, you'll be okay. It's your first. Like I said, if you differentiate a constant, you get 0. So I'm just going to take that 0 off now. That 0 was when I differentiated the 3. So it's going. Okay? You can put it in, and then on the next line, get rid of it. Okay? You don't need to show it, but when you differentiate a constant, you get 0. All right? Now, the next one. I've lost everything. No, I can't find the recording. There. It's 4t cubed, which is 20t cubed, minus 7 times 2t is 14t plus 3. And the last one, x equals 2x squared minus 5. Find the gradient function f dashed x. And then hence find the gradient of the function at x equals 2. So your f dashed x is 2 times 2x minus. If you differentiate 5, you get 0. If you differentiate a constant, you get 0. So I don't need the 0 there, do I? So it equals 4x. And then we say f dashed, remember we were doing this before. F dashed what? Negative 2, using function notation. So when x is negative 2, you can either write when x is negative 2, or you go f dash negative 2 is 4 times negative 2, which is negative 8. So the gradient of that function is negative 8. Remember, we were doing that with all that curve sketching stuff we were doing when I was showing it to you on the on that program. So f dashed x is 4x. So therefore, that's your gradient function. You can substitute any value of x you want into that gradient function to find the gradient of the tangent to the curve at any point. Okay, the next one. So given that y equals x squared plus 5, differentiate y with respect to x. You can do y dash or dy dx. Given that y equals x squared plus 5x, differentiate y with respect to x. You could have written dy dx equals or y dash equals. So we've got y dashed is 2x plus 5. Hence find the gradient of the tangent to that curve at that point. What do I do? What do I sub? What do I sub? The x value, the y value, what do I sub? What were we doing before? No, we don't do that. No, we just go when x equals 4, y dash is 2 times 4 plus 5. No, we already know the equation. That was different what we were doing before. So the gradient, remember the gradient function. When you substitute different values into the gradient function, you can get the gradient of the tangent at any point. Before, when we were working out what the gradient function was, because we were trying to work out what the a was. So my gradient function is that. Now when x is 4, so I'm not worried about the y values. You always substitute in your x value. When x is 4, you get 2 times 4 up here, 2 times. This gradient function gives you the gradient at any x value you want. You just have to substitute in that x value. So when x is 4, y dashed is 2 times 4 plus 5, which is 13. Now it says, hence find the equation of the tangent to the curve at x equals 4. You know the point, you know the gradient. What do you use? We've got our point and we've got our gradient. So we know our point is 4,36. Our gradient is 13. We're going to use the point gradient formula, which is y minus y1 equals m bracket x minus x1. Whenever you've got a point and the gradient of the line, you use the point gradient formula. So we've got y minus 36 equals m, my gradient, 13, x minus 4. Y minus y1 equals m bracket x minus x1. We substitute into that. We expand. Then we've got y equals 13x minus 52 plus 36, which is minus 16. So the equation of the tangent, of course, it's got a straight line. Tangents are always straight lines. And it's got a gradient of 13. It's very steep. And the tangent passes through. Its y-intercept is negative 16.